Hello guys, in today's video we are going to discuss the SAT problem, also known as the Boolean satisfiability problem, or in other words, searching for variables arrangement which will satisfy a given CNF formula. But before getting into the action, let's match our expectations. I'm studying this topic by myself, and my videos depend on the wisdom of the crowd, a topic that interests me a lot. So if I provide any wrong information, please correct me in the comment section below. I promise to read all comments and re-upload if necessary. Also, please subscribe to my channel to encourage social studies even from home. Alrighty, so our task here is to show a Karp reduction from the SAT problem to the half-true SAT problem. For starters, let's remind ourselves what a CNF formula is. A CNF is a formula contains clauses, and each clause has literals connected with a logic OR. The clauses connected with logic AND. A satisfied CNF formula is a formula in which at least one of the variables in every clause is satisfied. The SAT problem search for an arrangement that will satisfy all clauses. The half-true SAT problem set another requirement on top of the requirement of the classic SAT problem. It requires that the arrangement returned will include half variables set to true and half to false exactly. On a side note, Cook-Levin theorem discovered by the scientists Leonid Levin and Michael Cook proved that the SAT problem is NP-complete. Let's proceed with the idea and solution. Okay, so for starters, let's look at the CNF formula. This is it. Now, the given values are going to satisfy all clauses. And why is that? Let's look at the first clause, for example. Although B is not satisfied, A is satisfied, and that's more than enough. Moving to the next. Although A is not satisfied, C does. C is false, and we're looking for false. That's great. Next one. B is satisfied. And finally, D is satisfied. Now, if for example, we would change the values of A and B, B equals true and A equals false, we wouldn't reach a satisfied formula. So now after we remind ourselves what the CNF formula is, let's carry on. This is the second example, and as you can see, two of the variables received the true value and two received false. In other words, although the first example is in set, the second one is also in half-true set because the arrangement returned has two variables set to true and two variables set to false, and that's great. Now, to enforce every given formula in SAT to also be in the half-true SAT, we will perform the following modification. Each formula given will be converted the following way. To each clause, we will add variables with the opposite value to the value set in the original formula. For example, this is the formula I used in my example, this one. Now, I'm going to modify it the following way. I'm going to add A tag and negated B tag, and same to all. As you can see, this is the original clause I received, and this is the modified part. Now, for the values allocated, I'm not going to change them in any way, but for the modified variables I added, I'm going to apply, the opposite values of the original respective variables. So if for example I gave A the value true, I'm going to give to A tag the value false. and if I gave to C the value false, I'm going to give to C tag the value true. Now, let's prove that there is a Karp reduction from the SAT problem to the half-true SAT problem. Okay, so our goal is, given phi in SAT, we can construct an input phi tag in half-true SAT. So phi tag in half-true SAT if and only if phi in SAT. First direction. Let phi in SAT. So there is an arrangement for the variables of phi that satisfied all clauses of phi. Using the given answer, let us craft phi tag in the way explained above. This one, yeah. We received a modified formula and a result which contains half variables with allocated true value and half variables with allocated false value. Therefore, phi tag is in half-true SAT as required. Second direction. Assume phi tag in half-true SAT. So we have a satisfiable CNF term with half variables allocated a true value and half variables allocated false value. Since phi is satisfiable, phi tag is in SAT as required. In conclusion, we saw phi in SAT if and only if phi tag in half-true SAT. You can prove that phi tag has half variables set to true and half to false using induction. Well, that's the story. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that, even through complicated situations most of us are going through right now. Thank you so much. Good luck.